Hello students, welcome back to another question. Let's see what this question is. It asks, study the circuit diagram in which two resistors X and Y of resistance 3 ohm and 6 ohm respectively are connected in series with a battery of 2 volt. So here we have been given a circuit diagram in which there are two resistors, one of 3 ohm and another of 6 ohm. They are connected in series to a battery which is valued at 2 volt, and these are connected in series with a voltmeter measuring the potential difference across X and Y, and we have an ammeter which is connected in series. So the voltmeter is connected in parallel as always, and the ammeter is connected in series as always. So the question which is asked is, draw a circuit diagram showing the above resistors X and Y joined in parallel with the same battery, same ammeter and voltmeter. Alright, so we have to rearrange this diagram so as to represent it when the two resistors 3 ohm and 6 ohm are connected in parallel. The second question is, in which combination of resistors will the potential difference across X and Y and current through X and Y be the same? The third question is, find the current drawn from the battery by the series combination of the two resistors X and Y. So we have to find out the value of current, and the OR question is asked like, determine the equivalent resistance of the parallel combination of the two resistors X and Y. So when these two resistors are connected in parallel, what will be the effective resistance? So we'll solve all of these questions. So let's start with the first one. The first question asks us to rearrange the circuit diagram so as to connect 3 ohm and 6 ohm in parallel, rest all other parameters remaining constant. So let's start. So first let's start with the battery. So here is the negative terminal, here is the positive terminal. So this is the negative terminal, this is the positive terminal. So from here it goes to the switch. So here is the switch which is closed. Then we go to the ammeter. Ammeter is always connected in series. So this is the ammeter, this is the positive and this is the negative terminal. Then we go over to this point Y. So here is point Y, and at the point Y we have to connect these two in parallel. So here is one resistor which is connected in parallel with the other 6 ohm resistor. So this is the 3 ohm resistor and this is the 6 ohm resistor. They are connected in parallel. This is the point X. So here is point Y and here is point X, and this completes the circuit. So this is the direction in which current flows. Next we have to add the voltmeter. So at the point X we add the voltmeter here. Voltmeter we know is always connected in parallel. So this is positive and this is negative. Either you can do the voltmeter inside the circuit or you can do over here outside the circuit. So this is the answer to the first question, in which we have redrawn the circuit showing the 3 ohm and 6 ohm resistors in parallel. Now let's go over to the second question. In which combination will the potential difference across X and Y and the current through X and Y be the same? So in the second bit we have the potential difference across X and Y will remain same in parallel circuit, and the current through X and Y will remain same in the series circuit. That is, when 3 ohm and 6 ohm are connected in parallel, the potential difference will remain same, and when 3 ohm and 6 ohm are connected in series, the current in the circuit will remain the same. Why is it so? Because you see, in this parallel circuit, here the point X and this point Y, they are connected to the same source of potential difference 2 volt. So what will be the potential difference across the ends of the battery? The same potential difference will be across the end of these two resistors which are connected in parallel. So X and Y will have the same potential difference. They will have different current because when current passes through this point Y, it divides into two parts while it passes through the 3 ohm and 6 ohm resistor. Hence in this circuit, the current will vary across the resistors, but the potential difference across the resistors 3 ohm and 6 ohm will remain the same. Now in the series circuit, when the current passes through this point Y, you see current has only one path to go, that is passing through each of these resistors. So here the current value remains the same for both the resistors 3 ohm and 6 ohm, but the potential difference across 3 ohm and 6 ohm, they will vary depending upon the value of the resistances. So in the series circuit, the current remains the same and potential difference varies, whereas in parallel, the potential difference remains the same but the current varies across both the resistors. So this is the answer to the second bit. Now let's go over to the third question. We have to find out the current drawn from the battery by the series combination of two resistors X and Y. So in the series combination, the current will depend upon the overall resistance of the circuit. So first let's find out the overall resistance in the circuit. Then using Ohm's law, we will find out the current flowing in the circuit. So for the equivalent resistance when the resistors are connected in series, Rs is 3 ohm plus 6 ohm, that is 9 ohm. Now the potential difference is given as 2 volt. Now using Ohm's law, V is equal to IR. So I will be V by R. So putting the values, V is 2 volt, by resistance is 9 ohm, which is 2 by 9, that is 0.222 ampere. Hence the current in the circuit is 0.222 ampere. So this is the answer to the third bit. Now let's do the OR question. Determine the equivalent resistance of the parallel combination of the two resistors X and Y. So this is the OR question. Now here equivalent resistance is given by 1 by Rp is 1 by R1 plus 1 by R2, which is 1 by 3 plus 1 by 6, which is 1 by Rp is 1 by 3 plus 1 by 6, that is either you can write directly 6 here or you can easily write 3 into 6 for it. 3 cancels, it's 6 into 1 which is 6 and 6 cancels, so it's 3 into 1 which is 3, that is 9 by 3 into 6. This is 3, this is 2 which is 1 by 2. So this implies 1 by Rp is 1 by 2 or Rp is 2 ohm. So this is the answer to this OR question, that when these resistors are connected in parallel, the equivalent resistance comes to be 2 ohm. So this is the solution to this question. I hope you have understood this solution. If you found this video helpful, please do like this video, share it and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.